Hello, good evening, student. And in the previous lectures, we have discussed the new concept that is electrostatic potential energy or electric potential energy. In these lectures, we are going to deep the discussions of the electric potentials. Before the discussions of the concept of electric potential, we are must known about the units of electric potential. That is unit of potential energies. Unit of potential energy. We all are knows about the unit of energy or the SI units of energy is that is SI unit of energy. The SI units of energy is joule. The SI unit of energy is joule. And what is the definitions of the units of electrostatic potential energy? The unit of electrostatic potential energy. 1 joule of energy is stored in the charges which having the 1 coulombs. 1 joule of energy which are stored in 1 coulomb charges which are moving with the help of the potential difference is 1 volt. The 1 volt of potential difference between the unit charge, that is 1 coulomb, between their initial position to the final positions, then the energy stored in the 1 coulomb charges is 1 joules. It means the 1 joule energy is stored in moving charge which have 1 coulombs. Stored in moving charge which are 1 coulomb, and they are moving that the potential difference is must be 1 volt. This is all about the 1 joule charges. Joule is the unit of charges, joule is the SI unit of charges, and the CGS unit of the energy. Joule is not the unit of charges, joule is the unit of energy. Then the CGS unit of energy is erg. CGS unit of energy is erg. This is not a ARG, this is the CGS unit of energies. Now we are dealing with the electric potential energy or the electrostatic potential energy. The electrostatic potential energy is measured in the electron volt. It means charges or electrons, negative charges are moving, having the potential difference of that charges is 1 volt. We are also measured the electrostatic potential energy in the electron volt. It is electron volt. Electron, it is the charges, and volts is the potential difference between these two particles from the initial position to the final positions. Now the 1 electron volt energy is 1.6 into 10 raised to minus 19 times. The 1 electron volt energy is 1.6 into 10 raised to minus 19 times of 1 joules. This is the relationship between the energy having the different criteria. That is the 1 electron volt, that is potential, electrostatic potential energy into the energy. There are standard units of energies. It is most important asking in the MCQ must in the exam. Now we are dealing with the most important concept in the lectures, that is concept of electric potentials. The electric potential at any point in the electric field. Consider this is a charges, plus or minus. We can't be worry about it. The charges will be plus or minus. But if they are charged, then they produce some field surrounding these charges. This field is known as electric field. Then we want to find the electric potential energy or the electric potential at any point in the electric field is defined as the work done by the charges. Work done bringing the unit charge from the infinite to that point. From the infinite bringing this unit charge, that is I think Q. There are minus or plus. We don't worry about it. then the bringing of these charges at that point, and they required some work done. Work done is also the electric potentials. किती एनर्जी, किती वर्क डन लागतो इथून इन्फायनाइट पोझिशन पासून त्या पर्टिक्युलर युनिट चार्जेसला त्या पर्टिक्युलर पॉइंट मध्ये आणून ठेवण्यासाठी किंवा त्या इलेक्ट्रिक फील्ड मध्ये आणून ठेवण्यासाठी याला समजलं जातं इलेक्ट्रिक पोटेन्शियल्स. नाउ again the electric potential at any point in the electric field, the electric potential at any point in the electric field is defined as the work done by the charges bringing, by the unit charges bringing in the electric field or bringing in that electric in that certain points which they are working against the direction of electric field intensity. It must be important, against the directions of electric field intensity. Let us write the definitions of electric potential energies. Electric potential at any point, the electric potential at any point in the electric field, is defined as the work done to bringing the unit charge in the electric field or at that certain point, in the electric field or at that point, and the directions of electric potentials or the directions of flow of moving of these charges is must be against the directions of electric field intensity, and against the direction of electric field intensity. The direction of electric field intensities. Now we are calculating the electric field intensity. This is one charges or one particle. This is the another one. This is the Q1 and Q2. The potential energy of the two particles which having the charges, that is Q1 and Q2 also. I will be drawn one of the lines, the straight line between these two charges. It means the distance separated by these two charges is must be R. This says R. Now the potential energy between these two charges, the potential energy between these two particles which having the charges Q1 and Q2 is equal to Q1 Q2 divided by 4 pi epsilon 0 into R. Or this is not a divided, this is R, 1 upon 4 pi epsilon 0 into Q1 Q2 divided by R. Q1 is the charge at the point first, Q2 is the another charge which are placed in the another points. This is another points, and R is the separated distance between these 2 points which having the charges Q1 and Q2. Then the electric potentials, that is Q1 4 pi epsilon 0 into R, that is into Q2, is also is equal to Q2 divided by 4 pi epsilon 0 into R, that is also into Q1. Then these two electric potentials is must be equal, acting of the electric potentials on each other of these two different points having the different charges, that is Q1 and Q2. Then the quantities of the V of R, quantity of V of R, it is must R is must be constant or the unit separated distance. The quantity of R is depends on the charges, depends on the charge Q, because if the Q will be changes, the numerator of that potential energy or electric potential must be changes. And again the locations of another different charges, locations of another different charges, it means the separated distance between these two charges. That is, electric potentials is depends on the charges and separated distance between these two charges. Okay, let's start discussions. The quantities of V of R, the quantity of V of R is equal to Q1 Q2 divided by 4 pi epsilon 0 into R. It means the 1 upon 4 pi epsilon 0 is must be constant. We are taking to discussions of the Coulomb's law. This is the constant of Coulomb's law, and Q1 Q2 divided by R. This must be depends on the Q1 and Q2. It is the charges, and R is the separated distance between these two charges. Now, to finding the electric potentials in terms of potential energy. It is the electric potential in terms of potential energy. We are dealing with the electric concept of electric potentials. In the concept of electric potential, we must know about what is the electric potential. Electric potential at any point in the electric field is defined as the work done to bringing the unit charge, in that field or in that particular point of the system, and it is against the directions of electric field intensity. It acts against the direction of electric field intensity. Again the electric field intensity, again the electric potential is must be depends on the charges and the separated distance between these two charges. Then the electric potential in terms of potential energy, in terms of P dot E, it means in terms of potential energy, is two charges. Then the electric potential, that is, it means the U of R is equal to V1 R of Q2, that is must be also equal to V2 R of Q1. This must be important to solving or to calculate some problems, some numericals in the future when we are discussing CET, NET, JEE examples. Now let's going another side. The electrostatic energy or electrostatic potential is equal to the potential energy per unit charge. Electrostatic potential. The electrostatic potential is equal to potential energy per unit charge. Now we will be finding the difference between the potential energy. The potential energy is U and electric potential energy is V of R. The V is the electric potential and U is the potential energy. Then V is equal to U divided by Q. Or again writing V is equal to U divided by Q. Q is the unit charge, U is the potential energy, and V is must be electric potentials. The work done of the charges in the form of electrostatic force is equal to the change in potential energy, which are discussed in the previous lectures. Not be reminded, it is du is equal to f of E minus dr. This formula will be discussed in the previous lectures. With the reminding of the previous lectures, we are again solve the change in electric potential. Change in electric potential. Electric potential at a point second through the electric potential at point 1 is equal to, it is U2 minus U1 divided by Q, not a Q2 minus Q1, because this is the unit charges which could not be changes in the different places. Now we know that U2 minus U1 is equal to du, and this is the force into displacement. The charges will be displaced at a smallest distance dr, and this is the electrostatic force or Coulomb force. This is must be work done. Then the V2 minus V1 is equal to dw divided by q. The definition is electric potential at any point in the electric field is equal to the work done against the charges, work done of the bringing this unit charges in the place of electric field. Then the dV is equal to dw divided by q. This is the most important. And the energies, the unit of energy is a joule. Joule is one of the scientists. And energy, electric potential energy is electron volt. Then 1 electron volt is equal to 1.6 into 10 raised to minus 19 times of joule. It is minus 19 times of joule. We must know the method of writing the units of some different quantities. Then you will understand why I will be remove the smallest letter to the capital letters. Okay, let's revise what we are discussing in these lectures. We must know the electric units of electrostatic potential energy. The joule is the unit of electrostatic. Joule is the SI units of energies, and the 1 joule of the energy is stored in the 1 coulomb charges. 1 coulomb charges which are moving, and they produce the potential difference of 1 volt. Then 1 electron volt potential electric potential energy is equal to 1.6 into 10 raised to minus 19 times of the joules. Now after that we are dealing with the concept of electric potentials or electrostatic potential. The electric potential at any point in the electric field is defined as the work done in the bringing of these unit charges at the point in the electric field against the directions of electric field intensity. Then the potential energy of the 2 point or 2 particles which having the charges q1 and q2, they are separated by the distance r. It is u of r is equal to 1 upon 4 pi epsilon 0, not here, 1 upon 4 pi epsilon 0 into q1 q2 divided by r. Again, the quantities of V of R, quantity of electric potential is depends on the charges. The quantity of electric potential is depends on the charges and separated distance between these two charges. Now we are dealing with the electric potential in terms of potential energy. Electric potential is V and potential energy is U. Then the electrostatic potential or electric potential is equal to the potential energy of these charges per unit charge. Then the V is equal to U upon Q. Then the change in electric potential is equal to change in potential energy divided by unit charge. Then the change in potential energies must be work done, which are discussed in the previous lecture. Then we are find the change in electric potential is the ratios of work done divided by unit charge. Okay, we are stop here. In the next lectures, we are again discussions of the relationship between the electric potential and potential energy, and again discussions of the zero potential energy. Okay, now we are stopped.